Alright, I'll check it.
In the coffee.
No, we're checking. Did I not?
No.
Alright, if I didn't, I apologise, but let's have a look at exactly what I did give you and
In
did
the
not give you.
example you
No,
put
no,
the
don't ruin
coffee and
it,
the
don't
water.
ruin. Did I say that? Well, there you go.
The other one.
What?
What? Say what?
Yeah.
Oh, awkward. The question, I gave it to you.
Give us what?
In the example
Coffee.
we did say with the coffee in the class, you took coffee
As like water.
as a water.
But in the question, tell you
It
something.
was coffee, okay, but if the number he took, it was the water,
Physics.
4,200.
That's what I said.
Yeah.
Yeah. So,
So we use the water here.
See.
hold on, don't give me C. Right, so you have to use the water.
Now do I get the C?
I think Fahad's point is right. And the last question I said to treat the coffee like water.
But in the question you gave us, you did not say anything. Well, we're supposed to go to Google and look it up.
Actually, that really would have made me happy if you did that.
Mm.
It really would have. If you said to me, teacher, you didn't give me the heat capacity of coffee, so I looked it up in Google, you really would be making my day.
I actually did that.
Did you? What is the heat capacity of coffee? Actually, let's look it up. So, have a guess at what you think it would be.
Close to water.
More than water.
Huh?
More than water.
I think it would be, I'm imagining it being less than water. There's not much that beats water. I really remember looking the coffee up before, and I think it was something like 3,000 maybe. You know, it's gonna be less than water because really, water's tough to beat. Heat capacity of coffee. There we go.
4184.
418.
It's like nearly it's the same as water.
No, is it?
418.
No. This person here is saying,
These are people number.
oh, I know, but they're saying like smaller numbers than that.
Here this one, coffee and milk together,
They're
4184.
taking water.
So that means coffee should be 4184 minus the one of milk, 2850.
What is the heat capacity? Heat capacity of coffee. I found it a couple of weeks ago on like an article from 1924. Seriously. Well, we'll have to make up a number
Okay.
if we need to. Um, Heat capacity of water. Now, KJ.
1.434.
Nah, see, it depends if the coffee is dry or with water.
Yeah, okay, yeah, true.
So coffee, dry coffee, is that like coffee powder, I guess?
Yes.
That's 1,670.
Mhm.
But when you have an espresso, it's partly water.
Mhm. See experiments. Damn.
What answers did you get?
Yeah, this particular page. This is how to write a lab report.
Okay, I'm just gonna pick a number. How about we say
Water.
2,000
Let's use the one of water.
for the water?
Yes. That's the one almost everybody used.
Alright, well then, if that's what everybody used, we'll use that. So, right, what's the start of the question? What do I ask you first?
How long will it take to heat the water from 10 C to 100C by using.
Right, okay, so let me write that down. So part A, you're starting off with 10 Celsius and it finishes at 100 Celsius?
Yep.
And how much water do you have?
No,
100, 200 grams?
300.
300 grams.
300 grams.
So,
300 grams. So the delta theta is 90, the change in the temperature.
yeah.
So how much energy do we need MC delta theta, which is 0.300, 4,200 I think I said for water,
4,181.
4,181.
But we used 4,200.
But that was roughly he was using by himself.
I will just use 4,200, it doesn't
The
matter.
exact one is 481.
Alright, fine. 4181 times 90. So what's that number, please? Yeah.
One one two eight eight seven.
Say that again, KJ. 112.
887.
Now, that's how much work needs to be done on the water. I give you the power, don't I? What's the power of the kettle?
2 kW.
No, that seems kind of big.
Mistake. The change in temperature is meant to be 100.
I thought I said the water starts at 10 and goes to 100.
110. Goes to 110.
No, 100.
I didn't say 110 in the question, did I? That'd be crazy talk. Yeah, 100.
100, sorry.
Don't worry, KJ. I'll calculate it myself.
It is something else.
No, he was right this time. 112887. What's the power of the kettle?
2 kW.
2000, yeah?
Yeah.
And power is work over time. So time is work, which is 112887 over power. So you've got 56 seconds.
56 seconds.
56.4 seconds. Yeah?
Okay.
Yeah?
Yep. B part.
B part, what's the story?
How long would it take to heat the espresso from 10 to 80C by using a 3 kW coffee maker?
Right, so the M, how much is the M? 50 grams?
The espresso?
Yeah.
Yeah, 50 grams.
So, 0.050. The change in temperature?
10 to 80.
So that's a 70, isn't it?
Yeah.
Okay. And the C, we'll say, is like water.
4181. What's
I'll look it up when I get home. I'm curious now too. M C delta T. So you get the work 14634 joules. And the power is equal to the work over the time. So the time is equal to the work over the power.
3 kW.
3,000 you said?
Yes.
So, wow,
How many seconds?
nearly 5 seconds only. That doesn't seem right. I can boil 50 grams of espresso in 5 seconds in the microwave. That don't seem right.
Wait a minute. I'm sure there's a mistake somewhere. See.
Right, what did you say the power was?
3 kilojoule.
3 kilowatts.
Yep.
My goodness, that's amazing. 4.9 seconds.
But we don't know the
That's
actual.
for what? To boil it?
To boil 50 grams of espresso in the microwave. Oh, you know what? Microwaves aren't usually
It's
as...
100 grams of espresso, not 50 grams.
But then it just doubled this number.
Yes.
Is it 100 or 50 for espresso?
When you add
50 gram of whiskey, 100 of espresso, sorry.
50 grams of whiskey, 100 grams of espresso.
Well, you know what the problem is actually? I made my microwave too powerful. Microwaves aren't usually 3000 watts.
Yeah.
They're more like 800.
800. No, sorry. 1200, 800.
Yeah, okay. Well, anyways, we'll keep the numbers the same. So it's not... This is wrong. It should have been... Just double it, yeah. It should have been 29268 divided by 3000. Maybe I've got a super powerful microwave.
I'll check the
This is a more reasonable 9.8 seconds.
but still it's 100 grams.
Yeah. Okay.
We should try that.
Yeah, well, it'll be 3 times this Fahad because the microwave will only be like 1000 watts, not 3000 watts. I need to change that.
Third question.
Third question.
The cold whiskey at temperature of 23 is added to the hot espresso.
Now we have to be careful here, right? So we have our espresso. How much espresso do we have? 100 grams.
Yeah, do you know what you're asking?
No, well, let's just draw the picture first. It's going to be mixed together. 100 grams of espresso, and what temperature is it at the moment? Dude, what temperature did I heat the espresso to previously?
Previously, from 10 to 80.
80 is that now, yeah?
You say 10 to 80.
Yeah.
Yeah, I'm reading it.
Okay.
Right.
The cold whiskey was at the temperature of 20 degrees.
Cold whiskey at 20, and how much? 50 grams?
Yes. It was added to the hot espresso. Most likely at 80.
Like this? Okay.
Yes.
And they reach a final temperature. Will what will be the value of this? Will it be more or less than what and what?
More than 20, less than 80.
Yeah, be more than 20, less than 80.
Yep.
So the mixture, we picture it being like this, mixed together. So you have 0.1 here and 0.05 here. This will be at temperature X, and this will be at temperature X also, because they're mixed together. You know, the top half of your coffee won't be hotter than the bottom half, unless it's some fancy pants Starbucks latte with hot coffee at the bottom and marshmallows, frozen marshmallows on the top. So the whiskey here, is it gaining or losing energy?
Gaining.
It's going to gain energy, and this one is going to lose energy. When you mix these together to produce this, the energy which is gained by the whiskey must equal the energy which is lost by the water, so that the energy can remain balanced. So, let's calculate how much energy was gained by the whiskey by using our formula. It is M C delta T. Now what's the delta theta? What's the temperature change here?
No,
No.
sorry, mistake.
Yeah.
X minus
20. This must equal the energy which is lost by the what's 181 or something, lost by the hot water. So how much of a temperature change was the water? 80 minus X. So that's not too crazy to solve. I mean, after all, these cancel. You get 0.05 X minus 1 equals 8 minus 0.1x. So you get 1.05x equals 9. What?
No.
Nada. Back it up there, bud. No, sorry. What am I doing? 0.1 plus 0.05 is 0.15x equals 9.
Yes, fix this.
X is 60.
Hmm?
9 divided by 0.15 is 60.
So that was second then.
So the temperature is 60. Yeah?
Whiskey is not the same as water.
It's not?
Yes, whiskey
Ah,
is
nobody
alcohol.
told me.
Whiskey
Alright.
is alcohol.
Yeah, so what's the value for the alcohol then? I have to fix this now.
2300.
2300. Alright, let's fix this guy up.
I was born
Yes, of course you were, KJ. Of course you were. 0.05 times 2300 divided by 4181. So on the left, when you take, let's try that again. 0.05 times 2300 divided by 0.1 divided by 4181. So on the left, you get 0.275 x minus 20 equals 80 minus x. 0.275 x minus 5.5 equals 80 minus x. So 1.275 x equals 85.5.
So that's would be
67 degrees. Now what's the problem, KJ? Why are you wearing a hat and coat? Are you sick? You don't usually wear a hat and coat in class. Is it your new image or what?
No, it's cold.
It's not. Okay. Did you watch Flash last night? What do you think?
Very sketchy.
Sketchy. What's on tonight? Is Legends of Tomorrow on tonight?
I don't know.
Anyways, what's next?
one of my friend designed this.
Nice.
Let me
Yeah.
see.
He
Wait.
got yeah.
Go back a second. Spider monkey.
So
Anyways, that's cool. Photoshop?
yeah, he's actually very good. He got someone from Hollywood contacted him. He
Flash.
yeah, and he made this recently first project for $400. He got 4 projects. Comic book.
Does he draw it?
Is this all CGI?
I think so.
All computer generated?
Yeah.
Cool. Oh, that can't be CGI. That's Supergirl, isn't it?
Yeah.
But that doesn't quite look like the real actress. This is like a CGI image or something.
Yep.
All
So
cool.
similar.
All cool. All cool. Alright, what's the next part here? C, is it?
Good way to go to Hollywood.
It is a good way. What's next? C?
$1,600.
Huh?
We just finished the
Okay, D. What happens in D?
D.
Right, Karar, give me the phone.
no.
Give me the phone,
No,
Karar,
okay.
give me the phone.
In
Give me
D,
the phone, you can get it at the end of class.
Okay.
if you don't.
You don't need it during class, do you?
I'll
So-
put it there, okay?
no.
There, over there.
Give it to
Outside, no,
me.
Maybe some stinkers, coffee or something.
Give it to me, give it to me, give it to me, give it to me.
Okay.
Right, we'll leave it over here. Okay, you get it at the end.
Whiskey,
Now, what, the whiskey,
whiskey coffee mixture.
yeah,
Now have the hot water added to it.
yeah,
What is the final temperature of this mixture?
right, so, at the moment we have, how much coffee, how much whiskey, what is at the moment, it's 200 grams here?
No, 100 gram and 50 grams.
100 grams here,
Yeah. And
50 grams here, and they're both at temperatures of 67,
Sam.
67.
Yeah.
And then you come along with water, how much water?
300 grams.
300 grams at a temperature of 100?
Yes, definitely.
and you mix them all together.
Yes.
So you're going to have this mixture at the end, and they're all going to be the same temperature. We'll say X, X,
You
X.
don't leave 50 grams now.
It did, didn't I? That's 0.50.
Yeah.
Oh. 0.05, 0. No. We'll put the water on top. Now, what do you reckon the final temperature will be? Somewhere between
67 and 100.
67 and 100.
80. No,
Oh, the water's 80?
no, what is 100?
Yeah.
No, like I was guessing this right now.
Oh, okay.
Yeah.
So the what's this? Whiskey. Gain or lose?
Red wine.
And it should gain.
It will gain, and then the coffee here will also gain, but the water here will lose energy because, well, it's much hotter than the other two it's being mixed with. So the energy will leave the water and enter the other two.
Always the highest temperature. will
The
be-
highest to the lowest, yeah. So the energy which the whiskey gains is 0.05 m. Now what's the value for the capacity of alcohol?
2, 3 double 0.
2300,
Zero.
and the temperature gain will be X minus 67 plus 0.1 times what's this, 4181 times X minus 67. That must equal the energy lost by the water. This is water, isn't it?
Mm-hmm.
100 minus X. So I'll just write that again a little bit neater. 0.05 times 2300 times X minus 67 plus 0.1 times 4181 times X minus 67 equals 0.3 times 4181 times 100 minus X. So if we do some multiplying, 115X minus 3.35 plus 418.1X minus 6.7 equals well, hey, that's a huge number here. 125,430 minus 0.3x. So taking all those x's to one side, 418.1 plus 0.3 plus 115. On the left, I will get 533.4x, and on the right, yep.
If you multiply the it's just complete as an answer.
Do I need to answer anything?
No.
Great. 3.35 plus 6.7. Right, on the right I got 125,440.
3.3x is right?
I don't know.
I think it's wrong.
No, it is wrong because I got a ridiculous temperature.
Yeah.
0.3x is wrong. Oh, it is
You
wrong.
multiply
I forgot
the-
the 4181.
Yeah.
Right, so that needs to be fixed.
Well, that's what I'm saying.
Oh, but you said you didn't have a question. Should have
Why?
stuck with your question. Should have believed in yourself.
No, I had a question. I was like complete itself, so I won't, confuse you with the calculator.
You were thinking, nah, leave it, let it go.
Oh,
It's
yeah.
not worth it. It's not worth it. You'll just get angry at me again. But this time you were right. 4181. So the x should have been a much smaller or much bigger 1254.3 plus 115 plus 418.1. So now I get 1787.4. 125433 stupid answer. I did something wrong here. Can you check on your calculator, please? We go backwards. So the next thing I should have here, 0.3 times 4181. Yeah, I should have minus 1254.3x. Here's another mistake here.
It's not 6, 7.
It's not 6.7. The 67 times 4181 times 0.1.
Damn.
And it's not, yeah, 67 times 0.1 times 4181. That should have been 28012.7 equals. Right, now we rearrange 115 plus 418.1 plus 1254.3. 1787.4x equals 125430 plus 3.35
The last time
plus 280127. Oh my goodness.
in the last time when there was 6.7, we got 1787.
Alright, nobody talk to me while I do this. Right, now just be quiet. You're making me tired and hungry. Right, now, let's be very clear. I'm going to do this, and if you see one thing wrong, you just need to say stop. Got it? And if you say stop when there's nothing wrong, there will be consequences. Serious consequences. And just focus. Focus. Oh my goodness, focus! 0.05 times 2300. Right, so here I have 115x minus 0.05 times 2300 times 67, 7705 plus 0.1 times 4181 times x. So that is 418.1x minus 0.1 times 4181 times 67. 28012.7 equals 3 times 4181 times 100. 1254300 minus 0.3 times 4181 times x. Like this. Right, so 115 plus 418.1 plus 1254.3 x on the left, 1787.4x equals 1254300 plus 28012. Was that 0.7? I think so. Was it? Was it a 0.7? Anyone remember?
Yes.
It
No.
was? 0.7
where?
No, 7.7.
Yeah, it was 28012.7 was correct. Plus 1254300 plus 7705. No.
You made a mistake.
Yeah, but where?
115 plus 4181 418.1.
Is my number at the end here?
Are you sure?
No, not anymore. I'm not sure of anything anymore. Son of a gun. Ugh.
Wait, I think I got it.
One of the numbers is wrong.
I think your addition is wrong.
The axis.
I got 90.
Yes, because
115 plus 418.1 plus 1254.3.
I got 90.1.
Hold on. 1787.4x equals 1254300 plus 28012.7 plus 7705. 129017.7.
No, that's wrong.
But why?
I got 16114.
But now listen to what I'm typing in. Listen to what I'm typing in. KJ, listen. 1254300. Yes?
Okay.
Plus 28012.7 plus 7705. Did I miss anything?
no.
I got 1290017.7. And on the left, I have 115 plus.
Your number is wrong. 1254300. It's a single zero.
Oh,
Yeah.
Which one?
this
Yeah. Check
Yeah.
it.
one too many zeros.
Yeah.
Yes.
Well, why didn't you say that?
I didn't check it again because I got 90.
Teacher crying. 125430 plus 28012.7 plus 7705 161147.7
Yeah.
divided by 1787.4.
Bang, 90.
90.
90.2.
Praise Newton. Goodness sake. Need a whiskey. Right, what's the next part?
Last part.
Last part, thank goodness. What is it, F?
Yeah.
Yes,
It
it
is.
is a rather cold whiteness. The ground is at temperature of 1 degree Celsius.
No, you skipped a part.
The,
What
yeah.
about the part where the cup falls out the window?
Yeah, the Irish. The Irish coffee.
Oh, that was there are two more parts.
Yeah, so look here. This drink,
This is E.
yeah, E, okay. This drink fell out the window, and it was at 90 Celsius. Okay. And it gets a little bit warmer when it hits the ground. Yeah?
Okay.
Doesn't it pour?
Huh?
Doesn't it pour away? Like doesn't it
Let's
spill?
pretend there's a lid on it. Okay. So when this hits the ground, it gets a little bit warmer. Yeah? How much warmer? Well, how much energy does it get?
Potential
Potential energy. What's the formula for potential energy?
MGH.
mgh. So, what's the mass here? What's the total mass, please?
0.4.5.
What is it?
0.45.
And the G? 9.81. And the height? 100.
Why is it 0
That's what Fahad told me.
The total.
Total mass.
Which mass?
The whole
water,
drink.
coffee and the
Whiskey.
whole
The whole thing.
It's done Irish coffee
Yeah.
with whiskey and
True story. That's cream as well, but I left
There
that
are
part
people
out.
put whiskey or something in it. It's called Irish.
Exactly.
Yeah,
True
it's
story.
Irish style.
oh.
Irish coffee is coffee, whiskey, and milk and cream.
Ready?
Yes. Really true. Ask any teacher.
Mix it?
No. You have the
Don't ask like give me
you
Irish
have
something.
you have the whiskey,
Uh-huh.
and then you pour coffee on it, and then you pour cream on top, and then put extra cream on top.
Why?
Cause it's nice.
If you put something whiskey or something, it's called Irish.
Yeah, like Irish sausages.
Well,
Well, no, it'll say whiskey sausages on them because children shouldn't have them. True story. Right.
Serious.
I am serious.
Someday KJ will go the I need Irish coffee.
I am serious.
Do Starbucks have Irish coffee?
Does not. It doesn't have a license for alcohol, so you can be safe there. Because I'm sure you'll be very worried if that happened to you in Starbucks. Right, KJ? Right, KJ?
Yeah.
Right, the energy is 441.45. So MC delta theta is equal to the energy. So delta theta, MC delta theta is equal to that. So delta theta is 441.45 over 0.45. Now here's the problem. The heat capacity of the drink, what is it? You can't really know because it's all mixed together. It's almost like
But we can, take a
three
ratio.
different drinks.
We take a ratio.
Yeah. So I should have said this in the question, but what you could just do, and I'm adding it to the question now, you can just say approximate the drink as having C of about 4,000. Now it won't be as much as water. Why not?
Because water is denser.
No, why not? Because it's not a pure water drink. There are other materials in it which have a lower capacity. Do you know? So if you just have if you mix water with something else, it will still have a high heat capacity but a little bit less. So this drink here is still mostly water. So you could say it's roughly 4,000. So if I put that into the formula, so you get the temperature increase is about 0.25 degrees. It's about a quarter of a degree warmer when it hits the ground. What's so funny?
So small.
Yeah, well, it's only 100 meters, It's not going to reboil on the way down to Earth. Okay. Last part for this, yeah? What is the last part? F, is it?
Mm-hmm.
This is 5, yeah.
G then, is it?
No, this is F.
F.
Mm-hmm.
What happens here?
It is a rather cold night. The ground is at the temperature of 1 degree Celsius.
Yeah.
The coffee will give you heat energy.
The coffee will give heat energy to the ground. How much is it? Right, what's the temperature when the coffee hits the ground? Well, it will be 90.25.
Mm-hmm.
Right? So, if you leave this overnight, in the morning it will drop down to temperature of 1 degree, assuming it stays that overnight. So how much energy has this coffee lost? Or sorry, what was the temperature change for this coffee?
Temperature change is like
89.25. So the energy it lost was M, 0.45, C, which we're saying is about 4,000, and delta theta. Yep.
You minus it from 90 to 5?
Yes, 90.25 minus 1 to get the temperature drop.
Plus
161 kilojoules of energy was given to the ground from the cup.
So if a 100 cup is, first cup is of 1,000 first cup, it should fall to the ground. Would the ground have enough energy to cause an earthquake?
What do you think? What does your heart tell you? Are you trying to think about how you could be a superhero? Like Earthquake Coffee Man, is it? No, we haven't discovered a secret weapon here. If 100 coffee cups fall into the ground at this temperature, there'd be 100 times the amount of heat given off. But when we're talking about heat, that's actually a small number, because heat, like for buildings and things, you know, heating a building is quite an energy demanding job. You'd be talking about megajoules instead of kilojoules. It's not like Nigeria, you know, it's not like heat is something we easily have here. It requires a lot of energy, alright? So when you're talking about heat of coffee cup, this is tiny compared to what you would need in a home in Ireland to heat it up. Megajoules. Megajoules. Okay, did you write this down? Yeah? Alright.
Remember, never ask for